Okay, so day 2, solving by substitution. Same idea as yesterday, slightly more difficult problems. So notice we added some fractions in there just to make sure you remember how fractions work. Same idea though. We get one variable isolated. In this case, in our first example, we have y equals something. And so then we take our second equation and we rewrite it, but instead of y, we're going to put the value of y. So we would say, where do I want to put this? Let's put it right here. 2x plus 3 times all of that for y equals 11. So I'm going to replace my y with negative, oh, this isn't going to fit. Squeeze it in there. Okay. So now we distribute like we did yesterday. So be careful with your fractions. 3 times negative 2/3. Well, these 3's would cancel. This 3 out here and the 3 in the denominator. So that's just going to be negative 2x. 3 times 5 is 15. Bring the rest down. Okay. And then we run into a situation we didn't see yesterday, which is if we have 2x minus 2x, those cancel each other out. So all we're going to be left with is 15 equals 11. So if all the variables are gone, one of two things is true. It's either no solution or infinite solutions. And that's based on the resulting equation. So if this statement is true, the answer would be infinite solutions. But 15 does not equal 11, right? So this will never be true. So the answer to this one would be no solution. Okay. So that means those two lines are parallel, which means they never meet, which means there's no intersection point, so there's no solution. Okay. Now if you say, Ellis, how do I check that? Okay, good question. Good question. If you were to rewrite this bottom equation, if we put it into slope-intercept form, it would be no solution if they had the same slope, right? So if we rewrite this one, so if I do minus 2x to both sides, so that gives us 3y equals negative 2x plus 11, and then we divide everything by 3, we would get y equals negative 2/3 x plus whatever 11 over 3 is. Who cares? Really, the only thing that matters is we have the same slope on both equations, but we have different y-intercepts. So we have two parallel lines, no solution. Okay? You don't have to check it if you're fully confident that you did all your math right. If all the variables disappear, you're left with a false statement. It's no solution. All right, how about our second one? This one will actually let us do some math with fractions. So I underlined the wrong one. So we have y equals negative 2/5 x plus 2, and then 3x plus 4y. So I'm going to substitute in my top equation. I'm going to rewrite it. So 3x plus 4 times something equals 1. And then I'm going to replace that something with the value of y, which is negative 2/5 x plus 2. Okay. And then we distribute. So 4 times negative 2/5. So remember, we just multiply straight across. So that would be negative 8 over 5x. 4 times 2, much easier. It's just 8. So plus 8. Bring the rest down, so 3x plus that equals 1. Okay, so if I want to combine these two x's, and I don't want to change one of them to a decimal, if I rewrite 3 in terms of fifths, that would be 15 fifths. All right, 15 divided by 5 is 3. And then I can combine them. So 15 minus 8 is 7. So I have 7/5 x plus 8 equals 1. I'm going to run out of room here, so let's see if I can't shrink this down some. See if it'll play nice. Ooh. Ooh. Close enough. Okay. So let's switch colors. So let's do minus 8 to both sides. So we have 7/5 x equals -7. Okay. And then if we want to get rid of multiplying by a fraction, we multiply by the reciprocal. So times 5/7 over here. Over multiplying fractions, you go straight across. But since we have a 7, we can simplify. So this can be -1 times 5 is -5 over 1, or just -5. So x equals -5. Yikes, that was a lot of work. Then I put it back into an equation to get y. Let's put it back into this top one because, no, let's put it in the bottom one, actually, now that I think about it. Because that one's already set up for y. And since the denominator is 5, this is going to come out to a nice even number here. So -2/5 times -5 plus 2. This is a terrible looking 5. So 2/5 times 5, those 5s will cancel out. So we're just left with -2 times -1, which is +2. So 2 plus 2 is 4. So y equals 4. So our final answer here, I don't really have anywhere to put it. I used up all my space, but it's going to be -5, +4. Okay? So again, just like yesterday, all of your answers, no matter how bad the equation looks at the beginning, they will always come out to integer values, plus. Okay, so if you end up with any x or y values that are decimals, you made a math mistake somewhere, go back, try it again. Also, what they added is you're going to have some problems where they won't just give you an equation where the variable's isolated. So you have to do one of two things. One, you can keep doing what we've been doing, and you pick one. There's no wrong answer here. And you want to get x or y by itself. So for this first one, I would pick this top equation, since y is positive. So I can change this in one step. I just need to move the 2x to the other side. So this top equation we could rewrite as y equals -2x minus 2. And then we can work it out the same way. We can replace the y in this bottom equation with -2x minus 2, and then solve for x, and then plug it back in and solve for y. That's one way you can do it. The other way you can do it is you can either recall back to when you learn how to solve systems of equations by elimination, which is, this is a very good case for right here, because everything is lined up. And if we're doing elimination, we want it to be set up such that one of our coefficients for either x or y, if we combine them, will cancel out. So if we look here, if we added these two equations together, 2x plus 3x is 5x. That's not helpful. But 1 take away 1, that cancels out. So all that disappears. We're left with 5x equals, and then -2 plus 7 is 5. So we just added those two equations together, end up with 5x equals 5, or if we divide both sides by 5, we get x equals 1. And just like that, we're halfway done with this problem. We put that 1 back into one of our equations. So let's say this bottom one here. So 3 times 1 minus y equals 7, or 3 minus y equals 7. So -3 minus 3. So we get -y equals 4, or positive y would equal -4. So our answer 1, -4. There it is. Okay? Easy. So if you have a case where you have standard form, everything's lined up, you might consider using elimination instead of substitution. You just have to remember, sometimes if they're not exact, like in number 2 here, we want to make the coefficient so it cancels out. So if I have 1 here and 2 there, if I could change this coefficient to -2, like say if I multiplied the whole thing by -2, maybe. If we multiply all that by -2, we'd end up with -2x plus 4y equals positive 10. And then I get rid of this equation. I've just rewritten it. So I have a new system here. And then I can just combine these. So 2x minus 2x, that cancels. That was the whole point. Negative 3 plus 4 is 1y. Look at that. So nice. Negative 4 plus 10 is 6. And we have our y value. Nothing to it. So substitution always works. Sometimes elimination's better. So come back, ask some questions. We'll figure it out. Okay, bye.